go. Perfect. All right. Hello, hello, hello. Hello. All right. Hello, 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 everybody. Hi. I hope everybody's having a good morning. That'd be helpful if I actually do certain things. All right. There we are. I see Ola there. All right. All right. Good morning, everybody. All right. Hopefully, everybody's doing good today. Um, all right. We're back. We're back here on a. We're back once again. There you go. Another day, another week. Let's do this. All right. Looks like it's looks like I see one person in here, but maybe a few more will come in. So I'll start in about a couple of minutes here, and then we'll wait for other people to come on in. So, all right. Okay, that should be all right. All right, good stuff. Okay, so we're gonna get started here. So, no, it's just possibly one person, but hey, we're gonna see what happens here, and we'll get going. Why not? So, oh boy, boy, pretty cold today. All right, see if I can get over this cold that I got. All right, all right. Okay, let's get started today. Welcome back to Tuesday. Hopefully you have a nice weekend. All right, so for today, today we're going to be getting into the new material here. But before we do that, we have a couple of more examples here from the previous section to kind of do, which was talking about order of operations with decimals. We just may end up just doing an example of that and then just kind of moving forward there. Now, again, as I mentioned here last time, order of operations with decimals doesn't really change anything. Again, it's still the same order of operations that we've talked about before. Okay, so let's go ahead and just do this first one here, and we'll just see how this works out. So we'll do go ahead and do 2.5 plus 6.3 squared plus 9.62. Again, the 6.3 squared is going to be the first thing that we're going to go ahead and do. Again, 6.3 times, again, another 6.3. And you could go ahead and do this out. Again, you could try 63 times 63 if that makes it a bit easier. So you get 9, you get 18 here. And you cross that out, you get 9, 18 again. All right, so you have 9 and 7, carry the 1, 0 and 1. So we have 20, we have 2079. Again, this is 2 decimal places here since we have 1 in each. Okay, so notice I'm just going over this really fast. So we move over this 1 and 2. So we get 20.79 as our thing for 6.3 squared. Now all I have to do is just add up everything together. In this case, got to line up those decimals. So let's do that. And let's get 9.62. All right, we're just going to simply add here. 9 plus 2 is 11. Get 1 here. 13 plus 5 plus 6 says 19. 1, 11, 12. Okay, and carry the 1 here. So we get 32.91 is going to be our final answer for this problem. Okay, so by and large, that isn't too hard to figure out. All right, as you can see there, the order of operations pretty much is the same. Parentheses, exponents, multiply, divide, same rank. Add, subtract, the same rank. Okay, nothing really changes in terms of the methodology. All right, so there's that. All right. So that's kind of like again how order of operations work. Again, I'll leave it up to you because it just stays you put together all the other sections that we learned from that chapter. That's pretty much what you're doing. All right. Now we got to get into the next part here, which is section 5.1. That's going to be the new chapter here. So just know here that chapters 4 and 5 will be put together in the next test. Okay, so we haven't gotten to that point yet, but again, just for future reference sake, that's essentially what we're going to be doing. Okay, so what is section 5.1? Well, as you can see up there, section 5.1 deals with ratios. So let's go ahead and deal with ratios here. So let's talk about ratios. Now, what exactly is a ratio? Okay, so think of a ratio as like, let's say you're cooking, for example, and you're trying to put in, you know, 2 parts water for every part sugar, or something like that. If you're like baking a cake or something, I don't know. I'm not very good at cooking, but needless to say, there may be a ratio of a certain thing to another certain thing in some kind of random mixture, and we can express that in terms of a mathematical quantity. So, essentially, what does this what does this kind of say? Let's look at what it says here. It says a ratio compares 2 quantities. Okay, so, all right. So a ratio compares 2 quantities. Again, 2 parts water to 1 part sugar or something to that effect. Ratios must have the same type of units. Now we'll talk about what same type of units means because it's not water to water necessarily. It's a little bit different than that. So same type is kind of misleading in one sense. Okay. Okay. Let's talk about the next part here. How to write ratios. Well, how we can write ratios is listed here. Writing a ratio can be listed in 3 different ways, but it's important to note the last way here because it's the way that we're actually most accustomed to. So what you'll see is, like for example, a 7:3 ratio, as it says up there. So we could write here again, uh, 7:3. That's one way of writing a ratio. A 7 with a colon in front of it. Again, you read it the same way, 7:3. Or again, the last way that you see there is 7/3. So that's fraction bar represents the word 2. So what we want to do here is, again, write it as a fraction. That's going to be the most preferable in our case. So let's go and get this here. Okay. So I'll write this out here. All right. So what's going to be the most important here is that the fraction part, the fraction interpretation will be the most important. Okay. Okay. Now, are there any questions so far, by the way? I know there's a few of you in the chat there, but are there any questions at all so far? Again, if you have questions, type out your question in the chat. Otherwise, type out no. No? Okay. All right. Uh, really quick, Catherine, did you get the email I sent you? I hope you did. I just want to be sure that you got the email I sent you there. Okay, cool. All right. Just want to be sure that that went through. All right. Good stuff. All right. Okay. All right. Let's go ahead and take a look at how ratios are written out. Well, we say, okay, the fractional part is important, but how do you write out the ratio appropriately in the right way? Well, what matters is let's talk about the 2 keys to writing out ratios. All right. So let's talk about key number 1. Key number 1 is order matters, okay? Order matters when writing out ratios. This is especially true in this very first key, okay? Um, so what does this mean? Well, take a look at the box here. It says the ratio of 5 to 12. So in this case, if you say 5 to 12 here, all right, 5 to 12 here, basically what that means is we write it as 5/12, okay, as it's written here. But more importantly is that the first number here is the numerator and the second number here is the denominator, okay, of our fraction. So let's make a note here again. Um, and that's going to be key number 2 here as part of our order matters. Key number 2 is that the first number will be the numerator of the fraction, and then the second number here will be the denominator of our fraction. Okay. So that is why when we say 5 to 12 specifically, okay, and we say order matters, that's why our final result here would be just, again, 5 would be on the top and 12 would be on the bottom. Okay. Okay, so that would be our answer in this particular case. Okay, let's look at another example. Okay, and we'll see exactly how this works. Okay, so we'll just write up a couple of quick examples here. So I'll put it over here to the left so I don't erase what I just did. Okay, how about this? How about if I write it as 10 to 3? So how could I express this ratio as a fraction? If I write it like this, 10 to 3. So how do I write this as a fraction here? Go ahead and put your answer there in the chat. Okay, that's correct, right? 10 is the number that comes first, right? So we're going to put 10 on the top here. And 3 is the number that comes second. So 3 is going to go here on the bottom, or the denominator. Okay. So again, it doesn't go like small number, big number. It's just basically who's first and who's second. That's the only thing you care about. All right. So it's a quick example here, but again, one that should reinforce and be like, okay, yeah, I gotta actually do that one out and put the numbers in the right places. Okay, good stuff. Let's try. All right, let's try one more here. What about this one here? 1 to 5. How can I write 1 to 5 as a fraction? Again, all right, 1/5. Very good. All right. So yeah, pretty easy, right? 1 degree on the numerator, 5 to the denominator, and there you go. You got it. All right. So by and large, it's not very hard to do. All right. You just have to look at what order that they're written. Okay. Let's look at another couple of examples here. And I'm going to reinforce the point here. And you're probably saying, well, why? I want to show off that sometimes wording can be a bit tricky. So let's put a little bit of note here for these keys to kind of go along with these keys here specifically. Note here, watch out for the wording in some problems. This is going to be important here because let's look at this here, for example. So let's look at this first example here. So ancestors of the Pueblo Native Americans built multi-story apartment towns in New Mexico about 1,100 years ago. A room might measure 14 feet long, 11 feet wide, and 15 feet high. So 14 feet in length, 11 feet wide, and 15 feet high. So again, we have length, width, and height here in this particular problem. So again, read that carefully. It's one of the things, wording in these problems can be fairly tricky. All right, we're going to write each ratio using the room measurements. Okay, So write the ratio of length to width. So what would be the ratio of length to width according to this example here? What is the ratio of length to width? Again, once you got an answer there, type it out in the chat. Or just take a guess. Or if you're not sure, just say you're not sure. Oh, okay. Well, that would be a problem. Hmm. Let's try this. Actually, let's go with this. Is that a bit better? Okay. So 14, 14, 11. So, okay, so that's right to write as a ratio there, Ola. That's right. Now write that as a fraction. So you're correct there, Ola. It's just now just write that ratio as a fraction there, and then you'll get it. Okay. That's okay. It happens. All right, 14 over 11 is correct. Okay, good. That's right. So, I wonder if I can actually, yeah, maybe I can comment here. Or not. Sadness. Seeing if I can highlight on there. I guess not. Oh well. Oh, maybe I can. All right, so what we get here is 14 over 11. All right, good. So far, so good. Cancel. All right. How about the ratio of width to height? What's that going to be? The ratio of width to height. All right, 11 over 15. So it's 11 feet wide over 15. Okay, just like so. So here we have, again, 11 over 15 here as our answer. Okay, so again, you can write this also as 14 at the 11 here. You could also write this as 11 and then a 15 there. Okay, so just a couple ways to write that out. All right, any questions about that? Okay. All right. Okay, let's look at the next part here. Okay. All right, let's have you guys try this one here. Okay. Since some of you came in a bit behind, that's okay. So let's write the ratios here. Try these three really quick. We'll spend about a minute on this. Okay, so Shane spent $14 on meat, $5 on milk, and $7 on fresh fruit. Write each ratio as a fraction. Ratio amount spent on fruit to milk. Ratio spent on milk to meat. Ratio spent on meat to milk. Okay, So go ahead and give these a quick minute here, and when you have some answers there, go ahead and post that in the chat there. Okay. And the other two there to Ola? Okay. Okay. Yeah, fortunately for us, this is really quick. So, all right. Very good. All right. I think most everybody has that down. Yvonne's got 2 for 2. And the last one there? There we go. Perfect. All right. 3 for 3. All right. So this is pretty straightforward, right? Just have to go ahead, just say the ratio spent on fruit to milk. Again, correctly stated here as 7/5. So 7/5 for the first one. Milk to meat, again, 5/14. So that's the next one there. And then letter C here, which is 14/5. Okay, so there we go. We have our 3 answers there. Bada bing, bada boom. Got it. All right. Okay. Okay, now let's take a look here. Now that we have a good idea about how to write it as a fraction, one of the things that we do have to understand is that, yes, we may need to write ratios in lowest terms because we can express it as a fraction. So to bring this back here for just a second, and let's put another note here. Note, since we can write ratios in lowest terms, we may need to reduce if necessary. Okay, so we could reduce, basically, I should say not if necessary, but if possible. All right, so if possible. So it may not be possible because obviously, for example here, in the last example, we said, okay, it's 14/5. Well, 14/5 doesn't really reduce. There's nothing in common between 14 and 5. All right, so those things can happen there. But, if we can, then that's what we do. We reduce it down. All right. Now, there is one more thing I do want to put here as a very special side note as well, and that is in relation to lowest terms. All right. In this case here, uh, so what will happen here is we will keep basically we will keep both the numerator and denominator. Okay. So we will keep both the numerator and denominator after reducing. Okay, after reducing. So I'll go ahead and show you what I mean here by this little side note here. We'll keep both the numerator and denominator after reducing. They're probably saying, well, hang on a second. Isn't that obvious? You'd be like, sometimes people get a little confused about this. So I want to highlight exactly what I mean by that. All right, so let me Go ahead and shrink this down here, for example. And this very first example is a classic example of such. It says 60 days of sun to 20 days of rain. Now, by that point, so you can write 60 over 20. Now, 60 over 20 does indeed reduce, okay? Now, you can basically take out a 10. You could say you divide by 10 on both the numerator and denominator if you want to reduce. So you get 6 over 2. And then you can divide by 2 on the numerator and denominator. So here we get 3 over 1. Now, here's the important part. The important part here is that, yes, 3 divided by 1 is indeed equal to 3, but we actually want to keep this as a ratio. So what I mean by that last little note there is we want to keep both the numerator and denominator after reducing. If you see something over 1, we're going to keep that 1 in place because the ratio at the end of the day is going to be 3 to 1. Okay, so we want both the numerator and denominator there. We actually don't want to just make it just the number 3. And that's what this note kind of talks about down here, this cautionary note. So I wanted to show off and say, hey, you know, there can be a pitfall here. Okay, you did the reduction right, but with ratios, you want to keep both numbers in place. Okay, so that's the important part there. Okay, let's try another here. Yeah, we'll do a couple of these. Sure. Okay. 9 hours to 12 hours. Okay. Can you write that as a reduced ratio? 9 hours to 12 hours. How would that go? Okay. That's correct. That's right. Very good. So we have 9 over 12, okay, to start with. And then you could divide by the common factor of 3. And so here we get 3 over 4, or again, also 3 to 4. Okay. Good beans so far. All right. How about letter C? How about letter C? The ratio of the length to the width of this rectangle that is shown on the screen. One to two. Okay, so be a little careful there, Yvonne. Remember, length to width. So order matters here, Yvonne. So you have to go length here first. So length here comes first, and then width will come second. So okay. Oh no, no problem. That's why I'm here to correct it. That's okay. So 2 to 1. Okay, so 2 over 1. Okay, so we get 48 over 24. Again, you could actually divide by 24 outright. How do you know which is which? The length here is labeled here. So you have length and width here. So length comes first, so it's labeled as length here is 48. Oh, you're looking at the wrong one there. I'm looking at letter C, not letter B. No, not this one. Not 100 meters to 50 meters. Oh, okay. I was like, wait. Hmm? Okay, so this is going to be 2-1 or 2-1. Okay, good. All right. Any questions so far about that? Again, feel free to ask me questions if you're not sure, okay? If anybody's not sure, again, feel free to ask questions. Okay, now, let's take a good look here at this third example. Now, this is where wording is super important. For the second one, you would divide 50 into 50 and 100. Yes, that's correct. Right. So you'd have 100 over 50 here, and then you divide by 50 on the numerator and denominator there. Yep. Yep, no problem. Okay. Let's take a good look here. It says the price of a Sunday newspaper increased from $1.50 to $1.75. Find the ratio of the increase in price to the original price. Okay, let's talk about this one here. This one here, basically, I'll just put this straight up as is. I'm going to add a little comment here. That is, I'm going to put this actually in red. So wording is very important here. So if we're going to get this problem right, we need to look at the wording here specifically in order for us to get this down. Okay, so let's look at this particular guy. We want to say, hey, wording is super important here, all right, without question. So we're going to see exactly how this works. Okay, now the first thing that I'm going to focus on here is the increase in price. So the price of this newspaper increased from $1.50 to $1.75. So what is the increase in price? $0.25 is correct. So the increase in price here, the increase is going to equal $1.75, again, minus the $1.50 that you had from before. And so that's going to equal 25 cents. All right. So what we're going to do is we're going to have 25 cents here on the numerator, since that's the first thing in the written out here in this case. Then we'll have this 2, and then we have the original price. What's the original price of the newspaper? What's the original price of the newspaper here? $1.50, that's right. So the original price here is the $1.50 that we started with. The increase in price here being the 25 cents between the old price and the new price. And now we want to go ahead and figure out how to basically write this out. Now, You can write these as whole numbers if you want to. That's certainly possible. Or you could leave it like this if you're just using these 2's decimals as a ratio here. If you're leaving it like this, then this would be fine. If you're just leaving it as decimals like so, which is okay. That's not a big deal to actually write it like that. Or if you actually want to write it using whole numbers here, you say, okay, well, what is it, with whole numbers instead? You could actually do this, and this is relevant for the next one here. So you're actually going to multiply by 100 on both the numerator and denominator here. Now, the reason why I'm multiplying by 100 is so I can move this decimal place over by 2 places. So I'm going to move this over by 2 places to the right. So what I'm going to have here is I'm going to have 25 on the numerator and 150 on the denominator. Now I can go ahead and divide it out by 25 on the numerator and denominator. Again, this just makes it easy if you want to do it in your head. It's tougher with the decimal there. So here we get 1 and 6. So our ratio here would technically be 1 to 6. Or again, this would be another representation of said ratio. So 2 different ways to express the same thing here in this instance. All right, any questions about that? No? Anybody else? Any questions? No? Okay. Let's take a look at some more examples then. All right. So actually, let's have you guys try one. I think that'll be fine. How about, yeah, let's just try a similar one here. Try letter A here. Okay. And see if you guys can find the ratio here. Try and get it down to some whole numbers like I did the last example. So I'll put that one back up there so you guys can see what I did. And then once you have an answer, go ahead and post that in the chat. Anybody got an answer for me here? Okay. All right, so that's true. Now, can you give that to me in whole numbers, in lowest terms? So I agree with you, Ola. That's correct. But now you can reduce that further. Three over 11. Okay. Seems like a pretty good answer. Anybody else? All right. 3 to 11. Okay. Well, let's go ahead and give it a try. Excuse me. All right, let's see what happens. All right, so the difference of price here, indeed, if we take $7 minus the 550, that's going to equal $1.50. So the price increased by $1.50. So initially, that's correct. You have $1.50 to the original price here, which was 550. So what we do next here is with that 550, with that $1.50 and 550, we'll multiply by 100. That way we can get rid of those decimals. Technically, you can multiply by 10, but yeah, we'll just multiply by 100 here. That's fine. So we'll have this. Divide by 10. And so here we got 15 over 55. And then we can actually divide by 5 here. And so here we get 3 over 11. So that's correct here. The ratio of 3 to 11 here is going to be our answer for this problem. Good. Nice. All right. Nice work. All right. Hopefully that isn't too bad. Okay. All righty. Okay. Next is the mixed numbers. Now you're probably saying mixed numbers, that's a thing? I'd be like, yeah, mixed numbers are definitely a thing. All right, now mixed numbers here by itself isn't too hard. I'm going to go through one of these here, and we'll go ahead and see exactly how we can come up with those answers here. So let's go ahead and try letter B here. Now, letter A is actually pretty easy, but letter B here can be a bit tricky. Now, what's the key here to this problem? Let's talk about the key here really quick. So the key here to this problem is essentially going to be fairly simple. Again, we're going to convert each mixed number to an improper fraction. Okay? So convert each number to an improper fraction, and you should be good to go. Just like we've done it before in the past when we either, add, subtract, multiply, divide with mixed numbers, we convert it to improper fractions. Well, I'm going to ask you to do that again. Now, what is important though is to be very careful about this particular process. So I want to go through this example here a little bit slowly, okay, and show you why you just need to be a tad bit careful. Now, in this case, let's just convert, first of all, let's do the first part here, which is the key. 3 and a fourth here is going to be 3 times 4, which is 12, plus 1, which is 13. So we're going to have 13 over 4 here as our improper fraction there. And then we also have 1 1/2 here, which is equal to 3 over 2. So by and large, nothing's really changing about what we did from before. Same deals, fine. What really is important here is, again, because we can express this as a fraction of, say, one number over another number, one of the most important things is to do here in this problem is, and I'll put this as a little side note here. So note, put parentheses around each number. For mixed numbers especially, this is true. So I'm going to go ahead and put parentheses around 13 over 4, okay, and 3 over 2. Now, the reason why I'm going to do that here specifically is because when I write out my fraction for each, it's going to look like this. Okay, so this is what the ratio looks like right now as it stands with the two numbers here in question. Okay, now in this particular instance, all you're doing effectively here is dividing one fraction by another fraction. Okay, that's all you're doing here. So you're taking one fraction divided by another fraction. So we're basically, if you remember here, we have 13 over 4, let's say, divided by 3 over 2. Does anybody remember here? How do we divide fractions? What do we do? How do I change this problem around? Make the denominator the same. Not quite, Yvonne. That is for adding and subtracting, but not multiplication and division. So do note the difference there. It's a common mistake. People think multiply, divide is the same as add, subtract, but they are not. That's correct. Very good, Hannah. That's right. We're going to change it to multiplication and take the reciprocal for the second fraction. So we're going to flip. So if you remember here, let's put this in here. So remember, this is what we did quite a while ago, but we changed the division here to multiplication instead and flip this second fraction. Instead of 3 over 2, this now becomes 2 over 3. And now we can go ahead and reduce things down as we see fit. 2 and 4 go into each other, so we'll divide by 2 here. So this becomes 1, and this becomes 2. 2 does not go into 13, and 3 doesn't go into 13. So we'll have 13 times 1 over 2 times 3. And so finally we have our ratio here of 13 over 6. So you can write that as 13 to 6. And that's how we can express it using whole numbers. All right. Very nice work, everybody. Nice, nice. All right, let's have you guys try one, okay? Let's have you guys try letter B here. So this is the trickiest one. So we're going to take like 2-3 minutes for this one. So let's take 2 or 3 minutes for this one, and let's see how you guys do with the letter B here. So again, same vein as just the example here. So I'll leave that up. Let's take 2 or 3 minutes and give it a try, okay? 24 over 4. Not quite for that one. Hmm. 3 to 2. All right. Let's take a good look here and see. 3 to 2. I think 3 to 2 is probably correct, if I did my math right in my head. So let's see what we get here. So first, 5 and 5/8. So again, we have 5 times 8, which is 40. 40 plus 5, which is 45. So we get 45 over 8 for the first fraction. We'll look at 3 and 3/4 here. 3 times 4, which is 12. 12 plus 3, which is 15 over 4. So we're going to have 45 over 8. All right, and that's going to be in parentheses like so. And we're going to have that over 15 over 4. So here we have, again, 45 over 8 divided by 15 over 4. So again, we just flip that second fraction there. So we just try and see if we can find numbers in common here, and we certainly do. For example, 45 and 15 certainly go into each other. You can actually divide by 15 here. The whole thing actually divides out. So this becomes 1, and this becomes 3. Again, if you didn't see that right away, you could divide by 5 and then divide by 3 again. And here in this case, you could divide by 4 and divide by 4. 8 divided by 4 is 1. So here we get 3 times 1 over 2 times 1. So again, we get 3 over 2, or again, our ratio of 3 to 2. Now again, if you didn't get that right away, that's okay. You'd like to do another one? Sure, we can certainly do another one. That's not a problem. Before we do, are there any questions about that? About this one, I guess I should say. Maybe a little more clear. Which one are you talking about? Okay. Guys, if you think I'm going too fast, just let me know, okay? So, if you think I'm going too fast here, just let me know. I'm kind of glad I found this writing tool here, so fairly helpful to put it on the handout. Okay, let's look at letter C here then. All right. So let's do 3.5 to 7/8. So 3.5 can be rewritten as, again here, 6. We get 7 here, 7 over 2. Okay. 7/8 is exactly 7/8. So what we're going to have is we're going to have 7 over 2 over 7 over 8. So this is 7 over 2 divided by 7 over 8. So again, change this to a multiplication type of problem here. So this is times 8 over 7. So as you can see here, we have a 7 on the numerator, 7 on the denominator. So we can divide out by 7 here. So these both become 1. 8 and 2, so you could divide by 2. So we get 1, and 8 divided by 2 is 4. So here we get 1 times 4 divided by 1 times 1. So we're going to have a ratio here of 4 over 1. Remember, we have to keep the denominator here. So 4 to 1 here is going to be our answer for this problem. Okay, so that's another example that certainly you can see what happens there. All right, any questions about that that example there? So a lot of the things that we learned from before, like division of fractions and whatnot, yes, still do play a role here, just like they did before, okay? All right. And we do have to move on here, so let's go ahead and show this off here. Okay, same units here, that's fine. Okay. Let's look at this example here. It says write the ratio of the length of the shorter board on the left to the length of the longer board on the right. Compare in inches. Now, if you see here, this board length here is 2 feet, whereas this board length here is 30 inches. Although this is very, very misleading, the problem is that you have 2 feet and you have 30 inches. So these are two different units. So what you want here is, kind of goes back to our note from before, and we'll put this as a note here. So you want the same units to properly compare. So I want either inches and inches or feet and feet. Okay, that's basically what I'm looking for here in a problem like this. So effectively, what am I doing? Like if I look at this and I say, all right, let me convert 2 feet into inches. Well, 2 feet into inches is 2 times 12. So here we're going to get 24 inches. So if we compare the this board length that comes first, so the 2 feet board length compared to the 30-inch board length. So we're going to have the shorter board of 24. I'm going to put that over 30, which is the longer. So this is the short, this is the long. Go ahead and reduce this down. What can we divide by to reduce 24 over 30 down? What can that divide by? 6. That's right. So let's divide both the numerator and denominator by 6. So we get 4 to 5. Okay. And there we go. We got it. So again, remember, same units here. Okay, you want the same exact units. All right, very important there to properly compare. So your answer would be 2 feet over 30 inches. Remember to use your same units first. Okay. Questions about that? This is to convert feet into inches. So 1 foot is equal to 12 inches. So it's just like using a conversion there. So since I needed in inches, I had to multiply by 12. It's the same thing as if I did this problem here too, Hannah. So if I said, write the ratio of 28 days to 3 weeks. Well, 3 weeks, if I wanted to find out, well, how many days are in 3 weeks, right? We would say 3 times 7, because there's 7 days in a week. That would be 21 days. And then you could do the rest of the problem from there. Because you just wanted the same units, so you want it like days to days, that's what you want, or weeks to weeks. Okay, you can also pick that as well. So long as they're the same unit. So just using some small conversions there at the end of the day. Any other questions, or does that answer your question there, Hannah? Okay. Any other questions before we move forward? No? Okay. Okay. Here are some other measurement comparisons. So you don't have to worry about memorizing these per se. Eventually, over time, you kind of do, but yeah, you could just go ahead and use this here. A lot of things people know pretty much by heart, like time. Okay, 60 seconds is a minute, 60 minutes an hour, 24 hours in a day, 7 days a week. Pretty straightforward there. Um, Maybe the capacity people have a little bit of tough time with. 4 quarts is a gallon, 2 pints is a quart, 2 cups is a pint. Okay. Again, I'm not going to make you memorize these measurement comparisons necessarily. You guys can go ahead and refer to these if you need to use them for your ratio type of problems to put it in the correct amount of units. That's perfectly fine. So if you need to convert into feet from yards, then you know that 3 feet is equal to 1 yard. Okay. 5,280 feet is equal to a mile. Okay. Seems fair. Okay. All right. So I'll have you guys kind of do those out as is. Oh, man. Okay. Maybe I will just have you guys just do it out, period. Oof. That went fast. All right. Fine. Let's have you guys do a couple of these problems because I was going to start the next section and then I realized, whoa, we're almost at the end. All right. So, of class today. So I'll have you guys work on this. Let's have you guys just work on this one here. 7 yards to 14 feet. And we'll do that. Which one I want to do? Let's do that. We'll do this one here too, letter A. That's fine. Okay. So let's try letter A and letter C here as our 2 examples here. All right, so let's take a minute or two. Again, we want this as in lowest terms, and we want whole numbers here. Okay, so be sure to have whole numbers in lowest terms. Again, you can choose inches or you can choose feet. Second one here, you can either choose yards or choose feet, whichever way you want to go. Probably you want to choose feet for the second one. The first one you probably want to choose inches. So nice clean whole numbers. Oh, sorry. I'm gonna zoom out for this one because okay. Yes. Oh, yes, of course. Give me just a second here, Natalie. Of course. Let me go to the notes here. Oh, here we go. Sorry about that. Let me zoom out here for you as well. Sorry for the small writing. I just want to be able to get all the notes in there on one screen. If you'd like me to scroll up or down, just let me know. Okay, let's put this. No problem. Anybody else need the notes? Everybody else need the notes or no? I'll go shrink that down and put the handout back up. If you need the notes, just type yes in chat and then I'll leave them up. Okay. I'm gonna put up the handout then, and nobody's saying anything. Okay. Bring this back here. Okay. Check. Okay. Okay. All right. Well, let's take a good look here. If you didn't get this right away, that's fine. It's not a big deal. You guys can take your own time to do that. Let's look at letter C here first, since that's what I marked here first. 7 yards to 14 feet. Well, if you want to figure yards here to feet, 7 yards is equal to 7 times 3. So that's equal to 21 feet. So here we got 21 feet to 14 feet. So we're going to have 21 over 14. We actually can divide by 7. And so for letter C, at the very least, that's going to be 3 over 2. Again, a ratio of 3 to 2. So that part there is correct. Yeah, I knew what you meant. I knew what you meant. The first one there, Yvonne, you got correct. So very good. 3 to 2. All right. Now this next one here, again, a little bit trickier, but it's very doable here. 9 inches to start with. We have 6 feet. Again, 6 feet here is going to be 6 times 12 to change it to inches. That is 72 inches. So we have 9 inches to 72 inches. So that's going to be 9 over 72. You can divide by 9 on the numerator and denominator. So that's 1 over 8, or exactly correct here, 1 to 8. That is correct. Very good. All right. Nice work. Okay. Any questions about that? No? Okay. It's perfectly fine. Okay. All right. Very good. Okay. If there are no more questions, this is where we're going to leave off here for today. All right. For next time, I was hoping to get through to at least to the beginning of the second section, but I guess I'll just start off with the second section here for next time. So we'll start with the second section here for next time, which is section 5.2, talking about rates. And if we do, we can get to section 5.3 as well. Okay, so it just depends how fast we go, but we're going at a pretty good rate so far. So once we get done with chapter 5, we'll be in pretty good shape. So, all right. Okay, great job everybody here today. I really appreciate your time and your energy. All right, for coming out here to the stream once again. Does anybody have any more questions before we head out for the day? Okay. Well, if there are no more questions, thanks again, everybody. And I will see you all on Thursday, okay? Same time, same place. If you're here for my 11 o'clock class, I'll be back in about 10 minutes or so. All right. Have a great day, everybody. Have a great morning and afternoon. All right. And I'll see you in a couple days. All right. You guys know where to find me. All right. Take care, everybody. Have yourself a good one. We'll see you later. All right. See you later. All right. Bye.